Great. Let me just share my desktop. Okay, everyone can see a terminal?
Yes, we can.
Good, okay.
Oh, wait, yes, we can.
Okay, great. So yeah, like has been said, I'm working on the formal semantics of Rolang. For anyone who is unfamiliar with Rolang, Rolang is a language that's used for smart contracts on the blockchain, and its main computational step is sending and receiving information over channels. So let me just pull up some Rolang code. Whoops, sorry. Okay, so here's some examples. Here's an example of some Rolang code. We are sending a message and receiving over the channel. Chan is what we called it. In Rolang, channels are quoted processes, and our quote is this @ sign. And so Chan is the process, a string, and then we're just quoting it to make it a channel we can send and receive over. The second line is the syntax for sending. And in this case, we're sending a process which itself is a send, and we have a new channel, Chan2, and we're sending the empty process over Chan2. On the receive end, we are listening for a pattern here, and the pattern is something of the form, we want to see something on Chan of the form of a send over Chan2 of something. Whatever that thing is, we grab it and we quote it to make it a channel that we can send things over, and we send the empty process. So this right here should send, should evaluate to @nil bang nil. So let's just, I'll just run that really quick. Great. So this is what is called the configuration in the K framework, and this is what we care about. And it's exactly what we wanted. We wanted @nil bang nil, so we sent over the channel @nil, just the empty process. Okay, so K framework itself is a language that's useful for describing the formal semantics of programming languages. There are a few different purposes for having this. One of them, and maybe the most important, is that it serves as sort of a yardstick for compilers and interpreters. If you're writing a compiler for Rolang and the semantics are done, then you can test to see if you can prove that your compiler behaves just like the formal semantics do, then you can prove that your compiler works correctly. And this is actually genuinely an issue for some languages. The creators of K framework have a good example of a program that, depending on the compiler and the operating system, will compile differently. And this program is in C. And so so the goal here is to set up these formal semantics so that Rolang so that we can get good compilers and interpreters this way. Another use for K framework is you can prove that under some certain preconditions that some post conditions hold. And so if this is often used in industry to prove things about code that you might be giving to some contractor or something like that. And you can also even include a type checker and incorporate a type system into code and sort of look at programs and you can have a type checker. So I actually wanted to just run through the two first examples on the demo, like on the tutorial, on Rolang, which is online right now, and just show you how this works. So demo2.row. Okay, so this is the first example from the Rolang tutorial online. If you've been through that, then you'll recognize it. If not, it's a quick read to sort of get up to speed with what's going on here. What happens here is we create a new channel, Hello World. This is a private, unforgeable channel. We listen on that channel for anything, and whatever we get, we send over it the string Hello World. Concurrently, we make another new unforgeable channel called My Channel, and we send over Hello World. We send, we unquote it, and we send the process that corresponds to it. So both of these will correspond to processes which are not allowed in the syntax when you're writing programs, but they so in that way they're unforgeable, but Rolang still knows what to do with it. So we do something very similar here in the semantics. So let me just go ahead and execute this. Before doing so, let's see what we'll get out of it. What we should get out is, since this contract is permanently listening on Hello World, we should have that somewhere. And we should also, since we sent over Hello World the source code for my channel, we should get a message on my channel that is the string Hello World. So let's just do that real quick. Great, okay. So here is our contract. The persistent listen contract is syntactic sugar for a persistent listen, and that's here. And this #0 is the name, is like the source code for the unforgeable channel Hello World. #1 is the source code for the unforgeable channel my channel. And so what we've done is we've taken #1 and here's the channel. We've sent over it Hello World. You'll notice there's a bit of an issue of name equivalence here that in Rolang, not in row calculus always, but in Rolang, the quote and the unquote are inverses. And so this whole channel here is equivalent to, is the same as just that. So we've done exactly what we wanted to do. Okay, let's just briefly look at the second example from demo 3.row from the Rolang tutorial online. We'll create a new channel, Hello Again. We'll listen on that channel for anything and we'll throw it away. And we'll execute this body of code right here. And this body makes a new channel, sends the string Hello Again World on it, and then listens for it, grabs the text of the string, and then throws it away and just executes nothing. So this body right here will evaluate to nothing. Concurrent with this contract, we're sending over this unforgeable channel Hello Again. We're sending the empty process, which gets thrown away. So when we execute this, we should have a contract, a persistent listen, that will execute this since this body of code. Since this body of code evaluates to nothing, that should be the only thing left. So let's just look at that. Okay, so this is really ugly output from K, and I'm sort of working on possible ways to make it more beautiful. But this is actually exactly what we want. K uses these sort of backticks and single quotes and double commas to figure out what in the world is going on. And K will understand this as a persistent listen. Anyway, I've left a little bit of time for questions if anyone has any questions.
So it seems like you've got the pattern matching going on, which I'm delighted and surprised by. So you've got the more or less the full feature set of the pattern matching happening in your semantics.
Most of it works. Responsibly written, Rolang will execute mostly correctly right now. There are a couple of illegal moves that are still allowed in the semantics. And there are a couple of things that are still, that K will think they match when they don't actually match. So it is close, and I'm working on a few other things. I just finished with logical connectives in listens, and I'm going to do a couple other things and then try to fully get it all the way. It's almost there though. It's close.
Good. No, this is quite lovely. Do you have any sort of theorem provers or model checkers built into K?
No, not yet.
Okay.
Not yet, but that would be a really good thing to have, definitely.
So we know they exist because the K framework guy, Grigory Rosu, runs a business on proving things using K framework. We just haven't figured out exactly how to get access to them in the public version.
I actually have some. I have some contacts in England who use formal semantics to prove theorems, and so I will definitely be in. Yeah, it's out there. It just needs to. We just need to figure out where it is. And
yeah, I mean, also, I mean, the other possibility is looking at integrating with one of the existing theorem provers. What's this version of K? Is this written in Scala or Java or some combination thereof?
that is a great question. I know at least a part of it is in Java.
Okay, all right. So yeah, so if I recall correctly, that it's a combo of Scala and Java. In which case, integrating with one of the more modern theorem provers might also be an approach that we can take here.
That sounds like a very good idea.
Cool, awesome. No, thank you.
Just to be extra clear, the point of this K file is to specify what the semantics should be so that we can check the Scala code that we have written against it.
Mm-hmm.
In more practical terms, what we're going to take as canonical is the Scala code and modify the what it does. And
yeah.
The match. But then at that point, we will take K as the definition of correct, and then other implementations can compare themselves to that.
Yeah, that's a very reasonable approach.
Another nice thing about K is that you get a beautiful LaTeX file that has, colors and pictures and diagrams, and that sort of specifies things.
Oh, can you show us?
Oh, I don't have that. That sort of comes toward the end, I think.
Okay.
I don't have that yet, unfortunately.
All right. Well, that would be very nice to put up on the co-op website, or the dev website.
Yes.
When it's ready.
The intended output of Derek's work is a document specifying the operational semantics. That's
very nice.
Yeah.
Excellent. Thanks for the demo. Really, really nice work.
You're welcome. Thank you very much.